In this demonstration for the design apps developer role, we will see the usage of a user-defined app to build quadcopter assemblies. These designs will allow rapid prototyping and testing of quadcopters for various applications. We will see customized user interfaces, smart designs that adapt to standard parts, and validation operations to certify the created assemblies. To be reused by all the members in the design team, these operations are packaged in a custom app, which is easily deployed across the 3D Experience platform. So let's begin by launching the custom Quad Builder app from the 3D quadrant of the compass. A new product is created and a user-defined process is run on the product. This process will guide the designer in creating a new assembly from scratch. The process starts by capturing the requirements for the quad. Standard electronic components are displayed in a 3D viewer. This provides a simple way to visualize and identify differences between 3D content that is already available in the database. The user interface contains checkboxes for categories of components and a list from which the user can make a selection. Parameters created within the UI display the name and weight of the selected component. These, along with other component attributes, will be used to design the frame of the quad. The user interface also has built-in rules to avoid incorrect or incomplete user inputs. Once the selections are complete, the process calculates the total payload weight. The designer can also specify flight characteristics, like factors for wind and agility, and the required endurance per flight. After the quad requirements are captured, the process automatically selects power system components. First, an empirical equation calculates the total thrust requirement by evaluating the selected component weights and the flight characteristics. Based on this total thrust value, a motor-propeller combination is selected from supplier catalogs and specification sheets. Endurance and motor power requirements drive the selection of the battery. Finally, parameters from all of the selected electronic components provide inputs to an adaptive frame template. The frame itself consists of many design rules and formula to ensure sufficient rigidity. These selections and attributes are displayed to the designer. The designer can make changes to the payload and the program will update the automated selections. A naming rule sets the nomenclature which will be used throughout the assembly. Now the designer is guided to build the frame. The designer decides the values for certain critical parameters of the frame. Based on design rules, recommended values with limits are provided as a guide. If the values are out of bounds, rules in the process will automatically introduce the recommended value. These values are provided to the frame template, and the sub-assembly with all of its features is built and saved in the database. Rules within the process maintain the nomenclature throughout, which makes creation of BOMs easy and error-free. The app then picks the selected components from catalogs and places them within the assembly. Structural support members and bosses on the frame adapt to the component's design. The process finds and displays the value for center of gravity. It also allows the designer to optimize the center of gravity. The optimizer iterates different locations for components until the target value is reached. Optimizer algorithms can be set up to try different values for a variety of free parameters. This helps in achieving an objective target value. To complete the assembly, a landing gear needs to be attached to the frame. The program calculates the minimum required height based on the components placed under the frame. Once the designer selects the size, the process queries the database for parts matching this criteria. If there is a match, it will be directly placed in the assembly. As no existing parts are found for the values selected here, a new one is created using a landing gear template. An action within the template looks for the bottom plate of the frame and automatically positions itself in the assembly. It also finds the hub parameters in the bottom plate and modifies them for a perfect fit. Finally, once the assembly is built, the app guides the user to launch a certify operation. This checks the assembly against a predefined rule base. The checks sift through the assembly to find parts, measure distances, check for clashes, and compare parameters with predefined limits. This also provides the designer with useful information and suggestions. After modifying the design, the user can launch the certify operation through a dedicated command provided in the action bar. Such commands allow custom operations to be relevant throughout the design process. In conclusion, the design apps developer role allows company experts to create custom apps that capitalize on existing design methodologies, standards, and expertise. It allows to create and package rules, checks, and actions using only the enterprise knowledge language and its extensive library of functions. The creation of UI is simple and does not require special coding skills. These custom apps can be easily deployed for reuse throughout the extended enterprise. And they can be easily used by members of the company without strong technical expertise.